We're going to sketch a graph of a function that satisfies conditions that are specified as the limit as x approaches 0 of f of x is equal to 1. As x approaches 3 from the minus side, the limit of f of x is equal to negative 2. And as x approaches 3 from the positive side, the limit of f of x is equal to 2. F of 0 is equal to negative 1. That's a point. And f of 3 is equal to 1. That's also a point. Now, remembering that limits are two-sided things unless they're specified to be from the left with a little exponent looking minus or from the right with a little exponent looking plus. Let's go ahead and flesh this out. First, I know that I want to approach 0, as x approaches 0, I know that I want the function to approach 1. So what I'm going to do is I'm going to put a little open circle at the point where we would have 0, 1. And then as x approaches 3 from the minus side, I should be approaching negative 2. And so I'm going to put a little open circle at 3, negative 2. As x approaches 3 from the positive side, the limit is 2, so I'm going to put a little open circle at the point 3, 2. Then f of 0 is equal to negative 1. I'm going to put a point on the y-axis at 0, negative 1. And then for f of 3 equals 1, I'm going to put a point there as well. Now, as x approaches 0, my function is supposed to approach 1. And because the direction isn't specified for x approaching 0, I need to indicate that the function is approaching 1, both from the left and from the right. So from the left, I just have this swooping thing, and it doesn't matter what's happening over here, right? This is just an example of a function. You could have a horizontal line here. You could have a linear coming up to 1. It doesn't matter, as long as it's eventually becoming 1 from the left. Now I want to approach 1 from the right as well. And I went ahead and connected the point 0, 1 with the point 3, negative 2, because remember, as x approaches 3 from the minus side, my function is supposed to approach negative 2. Finally, as x approaches 3 from the positive side, my function value is approaching 2. So starting at that point 3, 2, I'll just draw something, and I just drew something that wiggles. And this satisfies all the conditions. It also satisfies the condition of being a function. Folks, sometimes people will make mistakes in that they might, instead of an open circle here, they might close it up and, well, hey, the limit here is 1. That's totally fine, except now we've violated the vertical line test. You would be amazed at how many calculus students forget the vertical line test when they're drawing pictures like this. And then likewise over here, I have open circles at 2 and negative 2 as x is approaching 3 from the right and from the left. And then at 3, I have a closed dot at the y value of 1. And I'm not failing the vertical line test. Okay, so when you're doing this, remember that limits are two-sided things unless they're otherwise specified, and the graph of every function has to pass the vertical line test.